Alright, so you've probably heard the term God particle thrown around like it's some kind of cosmic celebrity. But what actually makes the Higgs boson, the so-called God particle, so special? And how does it compare to all the other tiny particles zooming around the universe? Let's start with the basics. Most of the particles you've heard about, like electrons, protons, even photons, are the building blocks of everything. Electrons give us electricity. Photons are particles of light. Protons help make up atoms. They're all part of the Standard Model, which is basically the periodic table for particle physics. But here's where the Higgs boson steps onto the stage. All those familiar particles, they have mass. But for decades, physicists had no idea why. Why should some particles weigh more than others? That's where the Higgs boson comes in. It's basically evidence that an invisible field, the Higgs field, spreads through the universe. When particles move through this field, they interact with it. And that's what gives them mass. No Higgs, no mass. No mass, no atoms. No atoms, no you, me, or anything. Wild, right? Now compare that to, say, photons. Photons don't interact with the Higgs field at all. That's why they have zero mass, so they can zip around at the speed of light. Or take quarks, the building blocks of protons and neutrons. They do interact with the Higgs field, but each one a little differently. That's why they all have different masses. So the Higgs boson isn't just another particle. It's the smoking gun, the proof that this all-important Higgs field really exists. That's why when scientists finally found it in 2012, it was a massive deal, like discovering the last missing piece of a cosmic puzzle. So next time you hear God particle, remember, it's not about being divine. It's about making the universe possible in the first place. Pretty special, right?